done stepped in the game? At point blank range, who done stepped in the game? At point blank range, who done stepped in the game? Stepped in the game, stepped in the game.
Good evening. So this video is going to be pertaining to an announcement in a video unveiling Unreal Engine 5. And so I guess I don't want to go into all of the overview nonsense, because pretty much any channel is going to do that. I kind of want to get into the weeds here and talk about something that caught my attention. And I figure I'd share some information with you guys for a minute here. So the beginning of this video introduces one of the senior technical directors, Brian Karras, and he talks about how Unreal Engine 5 is going to leverage several different techniques and algorithms to make not only games look and perform better, but also make games easier to make for developers and studios with regards to art asset import and other things of that nature. One of the key features that he talked about with regards to Nanite being part of the Unreal Engine is something that's called Virtualized Geometry. So he dubs it Virtualized micropolygon geometry, where micropolygons are resurfaced and recreated, and you can basically infinitely create them. So you have a infinite amount of detail, rasterize them, shade them, and whatnot, and then dump the copies once the rasterization process is complete and is displayed on screen. So this sounds like a holy grail, and if you look at the demo, it looks great until you start noticing some things. And so what I did was I did some digging, because I noticed something familiar that I looked at way back when, and I went to go Google search, and lo and behold, instantly I was able to find what I was looking for pretty quickly. And so what I want to tell you guys first and foremost is I made a reaction video probably on Twitter. Some of you guys saw, and the first thing I screamed was old, and people were like, hey, what is he talking about? Old? What does he mean? Like, yeah, this virtualized geometry was something that Brian Karras has been pondering how to do as far back as 2009. He even wrote a blog post about it, and some of the issues he had with fill rate as far as polygon fill rate as early as during the implementation of DirectX 9. So one of the thought process here is for those who don't understand how graphics rendering pipeline currently works now, it's a rasterizing process, or a basic raise method in how mip mapping is done. You create polygons that create a shape. They cast shadows. They have textures on them. Then they're captured to pixel data, and they're flashed on the screen as pixel data. That will be your entire screen. All of the polygons, all the math for the polygons and whatnot, all the vertex data is being deleted in the background as you're being presented the finished frame, and then it starts working on the next frame to be completed, with more triangles, more textures, and more lighting for the next frame. And each frame in the graphics pipeline is created in that fashion. So part of that process is how textures are stored and how they're used in a frame. So there'll be several passes for each frame where textures are implemented and combined to create new shades and new texel data, which is a colored pixel. And it shows what kind of result you would get. So whether or not you would have, hey, this texture on this polygon facing this way or not, would be determined based on what grid of textures are currently facing on the screen. And those are implemented in pages of data for textures and texture layers. If you guys remember back to the 6th generation, is kind of how that was done. So there'd be a layer of textures, and so many could be done per pass or whatnot, and then they're presented per second based on how many you could process in 1 second. So what Brian Karas's theory was back in 2009 was, well, if textures could be multi-textured and texture pages could be held in stages with very little hit on hardware, as long as you have a newer GPU with that math kind of embedded, why can't we do the same thing for vertexes? Why can't we do basically a virtualized instance of vertexes ahead of time? So instead of needing 50 million polygons per scene or what have you, you could essentially do 5 sets of 10 million polygons per frame. And what is happening in the background is every other 100 milliseconds or so, vertexes are being displayed on basically a blank page that the viewer can't see, and all the polygons are being streamed in every 100 milliseconds or so to update data on the fly, instead of the GPU literally drawing all these polygons just to update one frame and then dismissing all the vertex data. It could stream the vertex data in as it needs it and update it as it needs it, and discard or duplicate any pixel data that it needs for polygons that have already been drawn. So he was thinking about how to do that, and back then there wasn't enough memory on the GPUs and to make something like that possible. So his idea was, going forward with the way tessellation was being done in hardware and newer GPUs going forward, then that could be something that could be advanced in a tessellator. So as you tessellate to create more polygons for a more detailed mesh surface, you could essentially send a vertex lookup through a texture lookup and make copies and clones of it. So instead of the GPU having to draw hundreds of millions of polygons per second, it's really only drawing like 10, and it's just doing them ahead of time and staging them. It's basically what it essentially is. It's pre-rendering for rendering. And it's kind of disingenuous when you think about it, because what's happening now is this Unreal 5 demo is showing you stuff that is real time, but technically is not real time, because what's being rendered and what you're seeing on screen essentially was rendered in the past. You're just looking at it several milliseconds later, or several hundred milliseconds later, after it's already been processed over multiple stages. The actual work of displaying all the vertexes and updating the screen instantly isn't really being done. So, and I hate to kind of poo-poo that, but that isn't what PlayStation 5 and Xbox Series X were designed for. They were basically supposed to be advanced versions of what we already have, with hardware ray tracing built in. And I guess the other interesting thing is that they have their own Lumen engine for global illumination, and I guess they'll support ray tracing in the future for DirectX ray tracing and whatnot. But they don't plan on doing it in the engine they just showed, and it was all global illumination. So it's probably ambient occlusion, I'm thinking of what they were using in this demo here. But it's so convincing because you can change the light source pretty much on the fly as they were walking through this demo. So what would be the need for actually ray tracing something to this effect? And the first thing I noticed was, well, water. Only true rays would be able to tell you, would be able to bounce through the diffusion of water, what have you, to give you a correct reflection or refraction, and give you a correct light bounce or give you a correct mirror sheen to correctly environment map whatever's in the background so it shows in the water what the reflection needs to be. The issue is, since you're doing this and it's happening in the past, things that require an instant update are going to be the flaw of this system. And if you noticed, this entire demo was basically a stolen Tomb Raider game. And what's missing from this stolen Tomb Raider game, you see a lot of dirt, you see a lot of rocks and craggy objects and whatnot, and there were some shiny statues showing up towards the end of the scene here. And they showed even towards the end where they were trying to show the advanced speed of the PlayStation 5 SSD, which for all intents and purposes just use more RAM and you could do the exact same thing. But as you flew through that area and all these special effects and whatnot, and you're going pretty fast, there was a distinct lack of foliage or anything else that would require, say, transparency, like a fence or something to that nature. Everything required a heavy use of geometry instead of things that would be transparent or translucent for you to look through. With the exception of the lighting particles and whatnot, but those are just microparticles that are also part of the graphics engine. Something like, say, a glass panel or a bunch of trees or bushes that need to interact or whatnot, those kind of things are going to be a problem because all of the physics that would interact with that type of stuff, to include the updating of frames and whatnot based on where you are within the foliage and how the trees interact and whatnot, that kind of demands that you have an updated display, and you're going to be off a couple of 100 milliseconds if you're essentially pre-rendering it before you're able to do anything. And that's where you're going to start having some issues when you have to bounce light in different places and whatnot and changing the values. It works in a dry area. It works in I won't say a non-reflective area, but a non-transparent area. A reflective area could still work, but when you start talking about transparencies and you have to see stuff behind other stuff, and if it's skewed in any way, that means that those micro polygons will need to update too, and re-update all the texture data that's being fed to them. And those are limitations of the cubics, I guess, was what they were using for the mega texturing that they were using. That's a limitation of that system. So I'm wondering how this is going to play out in, say, an Assassin's Creed game or something like that. This engine could solve a lot of problems for more limited hardware, like, say, Nintendo Switch and whatnot, but that would depend on how big the render targets are, because everything has to be written back to memory at some point as well. So if your render target is well over 3 gigs, that's still going to limit what you're doing. I'm still not sold on why you would even need to do anything like this with the amount of shading and the amount of post-processing effects that can be done on even lower end hardware today. It really doesn't seem necessary. It's kind of overkill at this point. And to do all these triangle setups and whatnot, you're bound to have some issues with drivers, or just in general with developers having all those polygons and whatnot being shaded and lit. There's going to be issues with collisions, because those are other things too. Like, you can't just have an environment that looks pretty, you have to interact with it too. So those sub micro polygons that the vertexes no longer have a reference in a table to map to because they were discarded, how do you go about making those polygons active again, other than requesting another update to have those polygons drawn on the screen again, so you know where the vertex hooks are, so the physics engine will work. So what it's going to sound like is the physics engine is literally going to be blindly looking at vertex data in a scene, for rigging and things of that nature, for anything like that to work. Now, they talked about the animation system that they have in house that I'm guessing is going to work against all those flaws. But if anybody is just going to use the graphics pipeline and not try to use the physics because, say, they want to use just Havoc instead, they're probably going to have a lot of problems. And I don't, for anybody that's seeing a lot of these AAA games now, these games are made in pieces. So there could be a publisher that says, hey, go get Unreal Engine, but all I want you to do is develop the graphic subsystem for it. And then they contract somebody else out to do the physics system. And now we have an issue in the project because the physics aren't compatible with what's happening on screen. And you end up with issues like, hey, this game looks really good, but my foot goes through the floor or stairs. And that can cause problems. But yeah, so it was just interesting to see that Brian Karras himself was talking about these very same issues in 2009. And while the hardware is kind of caught up to where he can finally make his idea real, some 11 years later, the limitations that he talked about are still very apparent, like right now, today. So, God, man, it hurts so bad. But I say it all the time on Twitter. Like, if we're truly having next generation hardware and we're supposed to advance games, why do we still have invisible walls? Why do we still have collision detection problems? If CPU processing has increased tenfold since the last generation, why is that still a thing? Why is game AI still so bad? If that's a thing, if we're making consoles with, what would be server grade hardware a couple of years back, you would figure that we would have AI that would be a lot smarter than a basically a bullet sponge at this point. It just bewilders me when it comes to that kind of stuff. I mean, ray tracing was promised 20 years ago as being the holy grail of graphics, and that it would eventually happen. And even now, with the hardware ray tracing that's on these new consoles coming forward, it's piecemeal. You have to pick and choose what pieces of ray tracing you want to use in the engine, because the built-in hardware can only do so much at a time. You can't do both water and reflection and soft bodies and hard bodies at the same time. You can't do global illumination if you're also doing soft body reflections on with rays being cast throughout the scene, because rays aren't really being cast across the scene with this hardware. They're being approximated. So even the current RTX on PC build works the same way. It approximates, if you had done raycast, what would be the result here on this local target. But things could change across, say, I don't know, a big environment, and you would have basically inaccurate shadows and shadow maps being drawn because your scene was too big, and the resulting shadows and whatnot are inaccurate from so far away, because it can only do so much without overloading the system, because it's very CPU intensive. So even creating a custom ASIC to do just that on a GPU for a console still is going to require a lot of oomph. So, and from what I understand, that's what Microsoft and Sony are going to do. They're binning a couple of the shader cores on their GPUs specifically for the use of these hardware based ray tracing ASICs that are being built in. I don't get the why one promise from 20 years ago can't be fulfilled. And this isn't. I don't think this is Brian Karras' fault. This is just him finally being able to go forward with a project that he had been working on the side, just solving problems within Epic. And Unreal Engine 5 was his chance to step forward and show what he was working on. While it's great, it looks great, there will be limitations. And I think it would be good for um, developers on the side of art assets, because they if you're making a movie game, you could literally just dump assets into your game and then it will be able to change everything on the fly for you. On the game side, and you actually playing a game, it doesn't necessarily translate into, oh, I'm going to get well above the performance of what this hardware could normally do. While you are pre-baking all of this stuff, that still comes at a cost, and that cost is time. So while we talk about PlayStation 5 and Xbox Series X having these insanely fast SSDs going forward here, supposedly in November, the whole goal of that is to have quicker load times. If what this engine is promising here, from what I'm seeing here and how this implementation works, everything is going to have to be preloaded. So what's the point of moving to a new generation, specifically talking about eliminating on paper load times and going back to good old cartridge days, if we still have to deal with games with loads depending on what engine is being used? It's just kind of weird to me. But if you pay attention, I didn't really see anybody touching on this, on what exactly virtualized geometry was. So yeah, I figured I'd talk about it. Basically, it's kind of a the other part that I didn't talk about was the instancing part too, which basically means that since it's virtualized, you can always revert back to an earlier state. So something like, how can I say this? If you have a set piece or a cutscene that needs to be, that say, in a demo a bunch of rocks were falling down and whatnot, you could instantly revert back and have all that geometry go wherever you want, really quickly, because it's being recalled back in time. You're calling back essentially texture pages, but I'm guessing these are probably dedicated vertex pages that are being made in this engine, specifically for that geometry. So as they're being created, there's a table tracking them side by side, saying, hey, this vertex was here, this vertex was here, this vertex was here, and then you could run back. If that instancing works as well as I think it does, it may actually solve the foliage issue going forward too. Where if you need an instant update, you may have to wait. It may not be instant, but at the same point in time, if anything repeats, and a lot of games repeat a lot, you can always go back to a reference point, which would be a quicker load than, say, requesting that vertex data again. So if you're, say, in a racing game and you know that you're going around the same loop over and over again, or it's, any type of small enclosed area, you can always go back to a referenced area for reused art assets, or just that same area again, regardless of what angle you're facing as far as the camera goes, because you're in that area. That vertex data is still staged in history, so you can just pull it back up, since there's a table tracking it in the background. Now, this probably sounds a lot kind of nerdy here, but it needed to be talked about. You have the Tim Sweeney's of the world and other developers that kind of want to talk over you. But essentially what's happening here is you're virtualizing polygons. You're saying, hey, look, instead of drawing these every frame, we're going to draw them before the frame, and we're just going to hold on to a bunch of them, and as you need them, we'll throw them at you. That's kind of the layman's term of this. And obviously the way they pitched it, it looks great. But as with all techniques, there's gonna be some cost benefit analysis there, and it's gonna take a lot of problem solving and a lot of working to see whether or not this works well on anything other than PlayStation 5 at this point, or anything other than this particular demo on PlayStation 5 at this point, whether it's other platforms, whether it's phones, Switch, or whatever, new hardware Nintendo is going to be working on in the next 2-3 years, and how that's going to play out, and how it's going to play out on PC, since all PCs don't have SSDs. But I guess leave comments in the comment section below, and let me know what you think about this. I am partially impressed about Unreal Engine 5, but I am partially unimpressed because it completely goes beyond what the console that they're trying to pimp is trying to do. Like, why do you have a completely different lighting engine from the ray tracing engine that's already built on the hardware? But I've already talked about that. Again, you guys let me know how you feel. Leave a like, dislike, or what have you. I don't really give a fuck. Like, however you respond works for me. So, and yeah, do you play games to have fun or to impress other people?